In this video, we'll be looking at the graph of the basic cotangent function. We know that the cotangent of theta is defined as x over y. It's the reciprocal of the tangent function. Therefore, the cotangent function is undefined when y is 0. Now we know that y is 0 anywhere along the x-axis. So we have asymptotes at 0 degrees, and then at 180, and then 360, and 540, and so on. We also know that the cotangent of theta is equal to 0 when x is 0. So that gives us x-intercepts, or zeros, at 90, and then 270, and then 450, and so on. So let's put this information into a graph. I've already drawn my dotted lines for the asymptotes at 0. Let me put this as a dotted line as well. It's hard to see when it's on the axis. We have 0 and 180, 360, 540, and then also to the left. We have zeros at 90, so let me mark the zeros. And I've also noted the radian measures of these angles in case you want to think in terms of radians. Now what I like to remember is cotangent and tangent are reciprocals of each other, so they have the same sign, which means that in quadrant 1, which is this space right here from 0 to 90 degrees, in quadrant 1 the tangent is positive 1, and the cotangent is also positive 1. So we can make a note that the cotangent of 45 degrees is equal to a positive 1. And then we also know that the cotangent of a negative 45 is a negative 1. So these are numbers that'll help us get started with our cotangent curve. So in this space right here, which represents quadrant 1, I have a cotangent of positive 1. And then I also know that in this space, which is negative 45, I have a cotangent of negative 1. And so I need to go along my asymptote and hit these 2 points. In quadrant 2, my cotangent is negative 1. So I can go ahead and put my values where cotangent is 1 and negative 1. I can put those in there. That'll give us some points to connect. So I have a cotangent curve that looks like this. It's very similar to the tangent curve, but our tangent curve is always increasing, and our cotangent curve is always decreasing. So that's one thing to keep in mind. And our tangent curve crosses at the y-axis, and our cotangent curve is asymptotic to the y-axis. That's another thing to remember. So attributes of my cotangent curve, it has a domain of, and I'll use set builder notation, the set of all x's elements of the set of reals such that x is not equal to, 1 pi, 2 pi, 3 pi. So all the places where the asymptotes occur. So I can write n pi where n is an element of the set of integers. My range, there are no values up and down where the cotangent is undefined, so it's all real numbers. We can show that this way. It's discontinuous at all the asymptotes, so x equal to n pi. We have x-intercepts at pi over 2, 3 pi over 2, 5 pi over 2. So those are the odd multiples of pi over 2. And you designate an odd number with 2n plus 1. And again, n is an element of the set of integers. My period is 180 degrees, or pi radians. And this is different from the period for sine and cosine. And it is symmetric with respect to the origin, which means that it's an odd function, and the cotangent of a negative theta is equal to a negative cotangent theta.